Well, welcome back. This is Unit 13, and in Unit 13 we're talking about nuclear reactions, and I'm Coach Forster. This is Coach Arthur, and we're first going to talk about the types of nuclear reactions and what exactly is a radioactive decay. So just a little review here first. We know that we've talked about the anatomy of an atom before many times, but we know that an atom contains
protons, neutrons, and electrons.
All right, so
it contains... And which of those are located in the nucleus?
Oh, the protons and the neutrons.
Protons and neutrons in the nucleus.
The nucleus contains we'll just put protons, and we'll just put neutrons again. So protons and neutrons are located in the nucleus. Remember, the electrons circle around the nucleus in the electron cloud. So this can be represented in a number of ways, but we usually represent it in shorthand notation. And here's the element Be, so we're going to have to look and see what the atomic mass is and what the atomic number of Be.
Well, the atomic number is 4.
It's 4.
So where does that go? I think that's the bottom one.
Yeah, that is the bottom one, yes. And
the atomic mass is 9.012182.
Okay, well,
we'll round that.
We'll round it to 9 for right now. So we know the number of the atomic number, which is the smaller of the two numbers. That is just the number of protons.
That identifies the element.
And then to get the other number, we're going to add up the number of protons plus the number of neutrons.
Why not electrons?
Because electrons are so small they do not cause any mass inside the atom.
That's right.
They're so small that they just hover around.
But those protons and neutrons are in the nucleus there. Those are the ones that are more massive.
The heaviest ones.
They affect the mass of that element.
So I can figure out the number of neutrons.
Very easy.
By easy, I'm just going to take 9 minus 4.
Top minus bottom.
Top minus bottom, and you get 5. So that's the number of neutrons you have. So 4 protons and 5 neutrons.
Okay.
All right, so that's the kind of a little review there about how to figure out how many protons, neutrons, and electrons in an atom.
Okay, I'm going to move this down, Coach Foster, to the next section here on nuclear reactions.
Nuclear reactions. So in a nuclear reaction, you have to have an unstable atom. Something that's unstable, and these are usually very large atoms. And most of the time, these are atoms above number 82. Okay, that have a mass above 82. And number 82 is lead. So anything above lead is considered radioactive. Atoms undergo spontaneous changes to change their numbers of protons
and
neutrons.
Again, we're working with what's in the nucleus here.
Working with what's in the nucleus. Just the nuclear reaction is only what's in the nucleus.
Right.
These processes give off large amounts of energy.
Just like most chemical reactions. Very, very large amounts.
In a very large way, and increase their stability.
So these atoms really want to undergo these changes.
They do.
So they become more stable. It's like they're searching for stability.
Yeah, like everybody. These changes are a type of nuclear reaction. I think this is a type of nuclear reaction that affects the nucleus of an atom. So a nuclear reaction affects the nucleus. We've already said that kind of. In a nuclear reaction, the blank numbers and the total numbers must be equal on both sides. The atomic numbers and the total mass numbers. So we're going to do an example down here, but those must equal when you add them together on both sides of the arrow.
You can't violate conservation of mass.
Right.
You can't add or create protons just out of nowhere or neutrons out of nowhere. Those things have got to come somewhere.
I wish you could, but you can't.
It'd sure be nice.
Yeah. So here is
like money.
Yeah. That's true.
Okay.
That's true. So here's a nuclear reaction where you have Be, and it's undergoing what we call alpha decay. So it's giving off a
helium particle.
Okay. So if we add these together, 9 plus 4, that's going to equal 13. So our top number over here is going to be 13. And 4 plus 2, so our bottom number is going to be 6. So now we can look up the element based upon the bottom number, which is element number 6.
Which is?
Which is carbon.
Carbon.
Hey, carbon. All right, so we have total number of neutrons plus protons is equal to 13. And then our total number of protons is equal to 6.
So these type of reactions change the identity of that element.
Change the identity.
It's changing the number of protons. When it undergoes a decay, or in this case, a reaction that took on an alpha particle, it's changing the identity of that element.
Right, so we go from 2 to 6. So when that number changes...
I just gave this away. I'm sorry, I didn't see that there.
When the atomic number changes, that changes the identity of the element.
Okay.
A blank is a change in the identity of a nucleus as a result in a change of in the number of its protons. A nuclear
reaction, I believe.
Yeah, nuclear reaction again. Nuclear reaction. And the change is number of protons. So we kind of restated there. So just in summary, these nuclear reactions are going to affect the nucleus, which affect the number of protons and the number of neutrons.
Right.
But there are specific types. We looked at one type here.
We looked at that type,
alpha,
with the helium particle.
With the helium particle. Now let's look at the other types, and we'll fill out the chart below.